Use the rational zeros theorem to find the zeros of p of x equals negative x cubed minus x squared plus 5x minus 3. Then use the zeros, the end behavior, and a few extra points to sketch its graph. To find the zeros of this polynomial, we can use the rational zeros theorem, which says that any rational zeros can be written as a fraction where the numerator is a factor of the constant term, negative 3, and the denominator is a factor of the leading coefficient, negative 1. So factors of the numerator are 1, negative 1, 3, and negative 3. And factors of the denominator are 1 and negative 1. So if we want to make fractions whose numerator is one of these factors and denominator is one of those, the only possibilities are 1, negative 1, 3, and negative 3. So we can go through and we can attempt to find the zeros here. Let's start with negative 1. If we want to test if negative 1 is a 0, we can use synthetic division. The coefficients are negative 1, 5, and negative 3. So when we do synthetic division, negative 1 times negative 1 is positive 1. When we add, we get 0. 0 times negative 1 is 0. When we add, we get 5. 5 times negative 1 is negative 5, and when we add, we get negative 8. Because this is not 0, that tells us that negative 1 is not a 0 of our polynomial, and so we need to move on and check another number. Let's check positive 1. We bring down the negative 1. Negative 1 times 1 is negative 1. When we add, we get negative 2. Negative 2 times 1 is negative 2. When we add, we get 3. And 3 times 1 is 3. When we add, we get 0. This is what we want, so that tells us that 1 is a 0 of the polynomial. And so x minus 1 is one of the factors. So we can write our polynomial now as x minus 1 times negative x squared minus 2x plus 3. Now our life will be easier if we have a positive leading coefficient here. So I'm going to factor a negative 1 out of everything in here and put it in the very front. So this is going to be negative x minus 1 times x squared plus 2x minus 3. And now we can easily use unfoiling to factor out that trinomial. So we end up with x minus 1 and x plus 3. Those have a product of negative 3 and a sum of positive 2. So this is a factored version of our polynomial with a negative out front just to make things easier. This means that the zeros are going to be 1, 1, and negative 3. So 1 is a 0 that appears multiple times. So we have our zeros. The end behavior, because this is an odd degree and because we have a negative leading coefficient, the end behavior is going to be going up to the left and down to the right with who knows what in the middle. So let's get an xy plane. And we can plot our zeros. We've got negative 3 and positive 1. We can plot the y-intercept. That's going to be negative 3. Remember, that's always just the constant term. And so we know the end behavior, up to the left and down to the right. And we know that in the interval between the zeros, we're going to be below the x-axis. But because we're also going to be below to the right of this point, because we know that from the end behavior, when we're below and below again, we need to have a nice smooth curve up there. So it's going to end up looking something like this. And up to the left. I want to draw your attention to this point right here. Sometimes students, because we're below the x-axis between those points, try to draw something like this, and then when they recognize the end behavior is going down to the right of this, they draw something like that. But this is not actually allowed for the graph of a polynomial. Polynomials are always smooth, the graphs, they're always smooth with no cusps. So we can't have it looking like this. We've got to make sure that it looks like this. And when we have a 0 that is repeated more than one time, this is often what causes us to have a maximum or minimum value right on the x-axis. Usually, if the 0 was only happening once, we would cross the x-axis and continue going upwards. But because this is a 0, we say, of multiplicity 2, it's happening twice, we're actually going up and then smoothly changing directions there and going down. And so this is our graph of p of x equals negative x cubed minus x squared plus 5x minus 3. The only part that might not be accurate is we might actually be going down even further here. We don't know from our calculations what the minimum value is, so we don't actually know how far down it's going to go. Again, we need calculus for that.